Hi, welcome to Math as a Language. Today's topic is the first that goes beyond our undefined terms. Remember our point, line, and plane, and those terms are not defined, but very important nonetheless. Today we're going to look at in today's video we're going to look at the ruler postulate. And the ruler postulate, as the name indicates, is a postulate, and a postulate goes beyond an undefined term. For the most part, a postulate is a statement that is assumed to be true. A statement assumed, and we know that we should not assume things in life, but in this case, usually we say it's assumed to be true. That is to say that you do not have to prove it. You do not have to prove the postulate. It's a statement that is assumed to be true. Okay. So let's take a look at the ruler postulate. Let's go back real briefly. And we started off with our point. Remember, we're going to make this point a little bit bigger so we can see it. But so we had our point here, and then we had these points that were put together to become lines, and of course the line became the plane, and these were our three undefined terms. Now the ruler postulate applies to the line. Let's take a look at the line. We're going to draw a line here, and maybe a little thinner, and in a color that we can see. So here's our line. Now, one of the things that we know about a line, and it's not defined to be, but we understand it to be, it's a collection of points. Now, the first statement in terms of the ruler postulate says that you have these points, and with any one of these points, you can associate a coordinate, and for every coordinate, there's a point. Then we say, well, what does that mean? You'll notice that when we draw the line, there's no numbers here. All right, it's just a collection of points. However, what the ruler postulate states is that for all of these infinitely many points, you can choose any one of them to be a coordinate. So if we were to choose this point, we can use this and put a coordinate, a number associated with this location on the number line. So if I want to call this 9, so be it. All right. If we were to draw another line, and there are no coordinates here. However, if you wish, you can go ahead and draw a little tick mark here, and you can call this -50. It really doesn't matter. We can go on with this forever. But the first aspect of the ruler postulate says that for any line, every line is a collection of points, and for any one of these points you can associate a coordinate. And so more often than not, what we will do, and in this case, we're going to associate that coordinate with the point 0. All right. So the deal is, on a number line, every point can be paired with a number. All right. So, and those numbers can vary. And also, not to belabor the point, it doesn't have to be a real number. It has to be an integer. You can associate this point with the coordinate -2.65 if that's your desire. It doesn't have to be a nice integer, so it's any number. All right, and we know, of course, we have infinitely many numbers in our number system. All right, so that's the first thing you can do. And now the second thing also says that the converse is also true. If you were to draw a number line, all right. Now remember, this number line goes on indefinitely from positive infinity to negative infinity. So simply put, this number line spans the scope of real numbers. So it goes without saying, finding it may be a challenge, but if you were to draw the number 6.8, there is a point on this number line associated with that real number. All right. So if you're given the number, you can say this is the point that's associated with 6.8. All right. So again, the original statement and the converse are both true. For every number line, there's a coordinate, and for every coordinate, there's a point on the line. All right. Now, beyond that, let's go ahead and get to the heart of it. More often than not, let's just go ahead and we're going to make it simple here. We're going to draw a number line, and we're going to associate a point. We've decided that that's the point, and that point's going to be 0. Now here's the other part of the ruler postulate. Just because this is 0, now what's interesting here is that you can't tell where any of the other values are. Just given one coordinate on a number line, you still have infinitely many choices as to where the other values are. All right, so let's cut to the chase. However, once you establish a second value, it could be 1, it could be any other number, let's say it's 2. But now once you have two coordinates on this number line, here's the second part of this ruler postulate. All of the other numbers are fixed. All right. So given one coordinate, you cannot determine where the other guys are. But now that you have two coordinates, if you have a coordinate here and a coordinate here, you cannot be arbitrary. In fact, we know that if 0 is here and 2 is here, 1 has to be midpoint between these two guys. That would have to be point 1. And similarly, if this is 2, we can say that an equidistance on the other side of 0 would have to be -2, and so forth and on. So given one coordinate by itself doesn't establish all the others. But once you have a scale here, once we know the length of this segment, either one of these segments, if we have two coordinates, then again, all of the others are fixed. All right. And so that's the second aspect. Let's now go on to one other thing. Once we know, if we have the coordinate, now the coordinate system is established, we now can talk about segment lengths. All right, so we're going to go ahead and make this a little broad and bold so we can see it. So we're going to talk about segment length. So we have a segment length here. That would be a segment of length 1. All right, starting at 0 and going to 1. So we can have this segment of length 1, and we're going to go ahead and name this. Because we're in geometry, we're going to remember in earlier videos we talked about the fact that we label our points in geometry with we label our coordinates with points, and we're going to call this point A. That's our point A here, and we're going to have point B at the other end there. Okay, so the length of AB would be 1. This would be 1 unit long, and the way we would say that, or the way that we would describe that, is this. We would say that AB is 1. Now please note that we're talking about the numerical value, the length of this segment, and therefore notice that we do not have the segment symbol above it. Let's go ahead and do another in a darker color, so that in bold, so we can see it. Let's go ahead and do a second segment here. Well, why don't we go ahead and, since this is here, we're going to do this segment, and we're going to call this point, let's make this point F. And we'll need to, yeah, that's fine. We can see that. So this F, that's A. And again, this length, of course, we can see our units here. This is 0 to -2, so we're going to say that AF is 2. Okay, and we can go on with that indefinitely. So now, the length of the segment is the number associated with this value with this distance between these 2 points. All right. So this value 1 is associated with the distance between A and B. So this is a distance. So the distance from A to B is 1. Similarly, you'll notice that the distance from A to F, and again, we're not talking about the segment, that distance is 2. So this is a distance. All right. Now, the reason why we keep making that point is this. If you want to talk about the segment and not the length, then you would have to say this would be AB. Okay. But because you're talking about the actual segment, you would have to put the bar above it. So in this particular case, we're going to make it a little bit bolder so we can see it. We would go ahead and put the segment bar above it. Now notice, when you place the segment bar above the AB, you're actually talking about this segment, the segment itself. However, when you do not put the segment symbol above it, you're talking about the numerical value. You're talking about the length. We're talking about the length of the segment. Okay, the distance between the two endpoints, and you're talking about the length. In this particular case, you're actually talking about this value. So you're talking about this value. In this particular case, this 1 is associated with this distance. All right, so that distance is 1 between the 2 points. All right, one last point, and we'll go from there. Let's go ahead and we're going to go ahead and label another point here. And we have let's go here. We're going to label this point. Let's call this guy C. All right. So now notice that we have a number of points on this number line labeled. We have F, we have A, we have B, and we have C. Okay. So in this particular case, the final thing we're going to do is we're going to talk about some distances here, some lengths. All right, we've done the length from A to B, and we've done the length from A to F. Now we need to do the length from C to F. All right. Now, when you're talking about distance, let's go ahead and get to it. When we're asking about the distance between 2 points, we have a symbol in mathematics. We have a symbol in mathematics that takes care of distance and is very helpful. It's extremely helpful. If you want the distance, if I want the distance from A to C, from F to C, so if I want the distance from F to C, we're going to first write it in words, from F to C. The way we would take care of that is we want the difference. You will want the difference between their coordinates. F has a coordinate and C has a coordinate. So what we would want, you want to take the difference. You want to subtract the coordinate of F from the coordinate of C. However, there's one important thing you want to recognize is that you don't want, when you're talking about a distance is a non-negative value. Distances are non-negative, and we want to make that distinction. So in order to recognize that it's non-negative, we use these symbols. They're absolute value symbols. Absolute value. All right. Now the absolute value, these symbols, when you put the bars around it, the nice thing about absolute values is that it allows you to not spend a lot of time worrying about what the coordinates of F and C are. In this particular case, we know that F is associated with the coordinate -2 and C is associated with the coordinate +2 or 2. So in this particular case, because we have the absolute value symbols here, we can just go ahead and place the coordinates of F in that position, in that location. So F we know was -2. Remember now we're taking a difference, so that subtraction bar, that subtraction is part of the process. So this symbol stays. Okay, that must be there. And C, let's go back and check one more time. Yes, C is the value 2. So we're going to go ahead and put a +2 there where the C is. And the nice thing about the absolute value bars, if you've worked with these in basic math, again, all of our basic math skills come to play here. We know that the absolute value, what we'll go ahead and do here is we're going to do it here. We're going to go ahead and say that that's going to end up being the absolute value. All right, absolute value. Now, -2 minus 2 would give us a -4, so that gives us -4. We have the -4 in the absolute value symbols, and the absolute value of -4, of course, is 4. Very, very helpful. So, in this particular case, and in all cases for the most part, what we want to remember is that the absolute value symbols, that allows us to always generate the distance. So whenever you see distance, we want you to have these guys be synonymous, okay, in your mind. Whenever you see absolute value, you want to think of distance, and when you say when they ask for a distance, you want to think in terms of absolute value. Okay. So absolute value and distance should be synonymous in mathematics. Okay? All right. We'll do more problems like this in future videos. But again, the ruler postulate, in order to, let's summarize the ruler postulate. The ruler postulate says, and again, the ruler postulate is a statement that is assumed to be true. Okay, you don't have to prove it. We recognize that if you have a number line, any one of these, it has infinitely many points on it, and any one of those points can be associated with a coordinate, any coordinate from the number line. But the converse is also true. If you're given a coordinate, you can also associate a point with that value. And then finally, given those two facts, we can now associate every point on the number line with a coordinate and every coordinate with a point. And that's essentially it. And we can use those coordinates, of course, to find distances. And again, we want to recognize whenever you see absolute value symbol and the absolute value operation is very important in finding distances. All right, thanks for visiting. Take care, and we'll see you in the next video.